So we've been talking about matter. We also need to talk about energy, because energy is a big part of why chemical and physical changes occur. So energy. Energy can be defined as the capacity to do work. Now these definitions are science definitions. They're a little different than how we use these words in regular everyday life. What is work? Work is defined as the action of a force through a distance. So if I take this wash bottle and I push it across the bench top, I did work on the soap bottle. Push it back, I did work on it. Now, nobody's going to pay you money to push a soap bottle back and forth, but that is work, okay? Work is a force acting through a distance. And energy is the capacity to do that. There are different types of energy. Two main categories are kinetic and potential. So kinetic energy is the energy associated with motion of an object. Potential is the energy associated with the position or the composition of an object. So an object can have potential energy because of its position. Up here we have a 10 kilogram weight sitting precariously on top of this building. This is elevated above the ground. It has potential energy due to its position. If we give that a nudge, it's unstable, it's going to topple off the building and fall. As it gets closer to the ground, its potential energy becomes less. But that potential energy is turned into kinetic energy, the motion of that weight falling. It's going to fall faster and faster as it gets closer to the ground. When it hits the ground, now it's got lower potential energy and it's going to stop moving through space. So that kinetic energy of motion is gone. What happens to all that energy? It doesn't just disappear. It's transformed into heat. Heat is actually a type of kinetic energy. Remember, I told you in a solid, the particles are not stationary. They're not moving relative to each other, but they're still moving, just like you guys are moving. So something that has higher thermal energy would be like the classroom where everybody's getting really antsy because she's been talking for so long and I just need to get up, and everybody's jiggling around, and that's a higher temperature of the substance. It would feel warm to your touch. So when this weight falls and its potential energy is turned into kinetic energy, and then it hits the ground, that kinetic energy of motion through space now becomes the kinetic energy of the individual molecules moving, which we observe as heat. We talked about how mass is conserved. Energy is also conserved. So we call this the law of conservation of energy. Energy can neither be created nor destroyed in a chemical reaction. So energy can it can change from one form to another. In that example, we saw potential energy changing into kinetic energy, and kinetic energy turning into a special form of kinetic energy called thermal energy. Energy can flow from one object to another. If you put your hand on a hot stove, the thermal energy from the stove is going to go into your hand. It's going to be uncomfortable. But the total quantity of energy is constant. Just like with that weight sitting on top of the building, objects that have high potential energy tend to be unstable, and they will change in a way that causes their energy to become lower. So chemical potential energy comes from the forces of attraction between the particles that make up atoms and molecules. These are electrostatic in nature. They're positive and negatively charged particles inside of atoms. It's the interaction between those particles that gives chemicals their potential energy. So in a physical or a chemical change, energy is always conserved. You don't make energy, you don't destroy energy. Systems that have high potential energy tend to change in a way that causes them to have lower potential energy. That energy that they had gets transferred into their surroundings. Here we have an example of a car. So the gasoline in this car comes into the engine and it undergoes combustion. Gasoline is high in chemical potential energy. When it burns, it releases that energy. The motor of the car, the engine of the car, takes that explosive gases and causes pistons to move and wheels to move and the car to move forward. So this potential energy, potential chemical energy in the gasoline is changed into forward motion kinetic energy of the car. Does all of the energy from the gasoline go into moving the car forward? No, it doesn't. Why do you never want to touch an engine that has been running for a while? It's hot, right? Why did it get hot? Well, because some of the energy escapes as heat and causes the engine to get hot. Some of the energy is harnessed and used to move the car. The rest of it escapes as heat. The same amount of energy is present in the universe, but it's been changed from chemical potential energy in the gasoline to movement of the car and thermal energy.